Now in this lecture, we trace the Cartesian curve of implicit curves. Cartesian curve, which is not a explicit curve, which is implicit curve. So what is the difference between implicit curve and explicit curve? In explicit curve, we are able to write down one variable, either x or y, in terms of other variable. But now if we see this example, trace the curve x cube plus y cube is equal to 3axy. Here we are not able to write down x or y in terms of other variables. So such type of equation is called implicit curve, where x and y cannot be separated. We have to trace the curve x cube plus y cube, which is equal to 3axy. Let us give it equation number 1. We we need to check the following points if you want to trace this curve. So the first point is about symmetry. Now here, since the power of x and power of y both are not even, so this curve is not symmetric about x-axis, not symmetric about y-axis, not symmetric about both the axes. Yeah, it is also, if we replace x by minus x, y by minus y, the equation of curve will change, so it is also not symmetric about the opposite quadrant. Yes, but if we replace x by y and y by x, the equation of the curve will not change. Therefore, the curve is symmetric about the line y equal to x. So this is the curve which is only symmetric about line y equal to x. Okay, now let us take will the curve pass through origin. So since there is no any absolute constant term present in the given curve, so the curve passes through origin. What is the tangent at origin? So we have to check that what is the lowest degree term at origin in the given curve. So lowest degree term is nothing but the right hand side, 3axy equal to 0. So let us equating it equal to 0. We are getting x y equal to 0, which gives us x equal to 0 and y equal to 0. X equal to 0 means y-axis, and y equal to 0 means x-axis. So now there are two different tangent at origin. One is the x-axis, another is the y-axis. Nature of the origin, since there are two different and real tangents at x equal to at origin, so origin is known. Intersection with coordinate axis, definitely from equation number 1, if we have x cube plus y cube, which is equal to 3axy. So if we put y equal to 0, we get the intersection with x-axis, and if we put y equal to 0, we are getting x equal to 0. Similarly, if we put x equal to 0 in 1, we will get y equal to 0. So curve meets coordinate axis only at origin, 0, 0. Let us try to find out the asymptotes. Since this is the implicit curve, so if we check that what is the highest power of x, it is x cube. What is the highest power of y, it is y cube, and their coefficients are 1, 1. So we are not able to find out the asymptotes parallel to x-axis as well as asymptotes parallel to y-axis. So no asymptotes parallel to x-axis and parallel to y-axis. But here we will get the oblique asymptotes, right? So it has oblique asymptotes. So how to get oblique asymptotes? So we know that what is asymptotes? Asymptotes is nothing but a straight line which is finite distance from the given curve and and touches at infinity. So let us take this y equal to mx plus c is the oblique asymptotes of the given curve 1. So let us put y equal to mx plus c in equation number 1. We have x cube plus y cube is equal to 3axy. So value of y equal to mx plus c. Let me just put over here x cube plus mx plus c whole cube, which is equal to 3ax into mx plus c. Let us simplify it. What is a plus b whole cube? A plus b whole cube is a cube plus 3 times of a square, b. So 3 times of b means c, or a square means m square x square plus 3ab square. So 3mx into c square plus b cube is nothing but c cube, which is equal to 3ax 3am x square plus 3acx. Now we will try to rearrange this equation in a descending power of x. So the first thing is x cube, again x cube, then x square. We again write down this x square left hand side, then the power of x, 3c square into mx, and then we take this point 3ac into x, and at the last we have the c cube. So we arrange this equation in descending power of x. Now let us try to find out the coefficient of x cube, which is nothing but 1 plus m cube, the coefficient of x square, which is 3m mc minus a, plus coefficient of x, which is 3 times of mc minus a plus c cube. So this is the highest power of x, x cube, x square, x, and constant term. Now we have to find out the value of m and c. So how to get it? So equating the coefficient of highest power of x and second highest power of x to 0, we have, what is the highest power of x? It is x cube. What is its coefficient? 1 plus m cube. So let us put 1 plus m cube equal to 0. And what is the second thing? 3m into mc minus a. This is the coefficient of x square. So let us again equating it equal to 0. So it can be written as a cube plus b cube. So 1 plus m into m square minus m plus 1 equal to 0. And this 3m cannot be equal to 0. So mc minus a equal to 0. So which gives us 1 plus m equal to 0. And if we write down m square minus m plus 1 equal to 0 and mc minus a equal to 0. So here m equal to minus 1. And if we simplify this one, we will get the value of m is imaginary. And here mc is equal to a. So if you put m equal to minus 1 over here, the value of c equal to minus a. Minus 1 and the value of c equal to minus a. So these are the values of m and c. So if we put these two values in the equation y equal to mx plus c, we are getting y is equal to minus x minus a as asymptotes of the given curve, and which is not parallel to x and y axis. So this is called oblique asymptotes. Now this y equal to minus x minus a can be written as, let us transpose this x to this side. So x plus y, which is equal to minus a. And if we divide whole equation by minus a, so it can be written as x upon minus a plus y upon minus a, which is equal to 1, which is a straight line cuts minus a intercept from x-axis as well as y-axis. So now if we want to trace this asymptotes, this is nothing but, suppose this is a, this is a, this is minus a, this is minus a. So the asymptotes is nothing but the line, this is the line. This is the line. This is asymptotes x plus y plus a equal to 0. Right? This is asymptotes. Okay, let us go ahead and try to trace the curve. Now, is it any special point? Because since the curve passes through, curve is symmetric about the line y equal to x, so definitely we have the special point. So how to get that point? Let us put y equal to x in equation number 1. So we have x cube plus x cube equal to 3x square. And if we simplify it, this is 2x cube, which is equal to 3x square and if we replace this to left hand side, 2x cube minus 3x square equal to 0. And if we take x square common from this point, this both the term x square is common, which gives us 2x minus 3a into x square equal to 0. And this is x equal to 0, and 2x minus 3a equal to 0, which gives us x equal to 3a by 2. So now we have, hence from y equal to x equal to y, which is equal to 0, if we put y equal to x, and x equal to y, which is equal to 3 upon 2. So there we have 2 points. One is origin. The special point is 3a by 2 and 3a by 2, because we have already obtained the origin when we discuss about the intersection with coordinate axis. So this is 3a by 2 and 3a by 2 is the special point. Now since we are getting the special point, so let us try to find out the tangent at this special point. So how to get tangent? We have to just differentiating 1 with respect to x. We have 3x square plus 3y square dy dx, which is equal to 3ax dy dx plus y into 1. And now if we simplify, what we are getting, this 3y square, 3 can be cancelled, 3y square minus ax into dy dx, which is equal to uh, ay minus x square. Ay minus x square. So dy dx is nothing but ay minus x square upon y square minus ax. Now, what is the tangent at this point? So let us put x equal to 3a by 2, y equal to 3a by 2. And if we simplify it, we are getting the whole value is minus 1. So minus 1 is what? This dy dx is nothing but tan theta. Tan theta equal to tan minus 45, or we can say that it is tan 135 degree. So theta is equal to 135 degree. So this is what? This is the uh, tangent at the point 3a by 2 and 3a by 2. So let us how to trace this tangent. So let me go ahead, and tangent at 3a by 2, 3a by 2 is line which makes 135 degree angle with x-axis. Reason of absence, from 1 we have x cube plus y cube, which is equal to 3axy. This curve is implicit curve, so one variable cannot be expressed in terms of other variables, right? So here, if we put xy equal to minus x minus y, then it will not satisfy the above equation, right? It means that there will not be any line on the third quadrant. It means the curve will not lie on the third quadrant. Hence, the approximate shape of the given curve is as follows. Okay, so let us discuss about one by one. The first thing, what is the tangent at origin? Tangent at origin is, first tangent is y equal to 0. Second tangent is x equal to 0. And we are getting the special point 3a by 2, 3a by 2. Yeah. So this is also at this point, what is the tangent? It is theta equal to 135. So this is the tangent. So there are three tangent, one tangent, second tangent, and third tangent. So what we are getting? We are getting loop at this point. We are getting loop at this point. And since this line, this x-axis is tangent, so what it means? We can write down this. We can write down like that. This is the tangent. Similarly, this is the tangent, so we can also write down like this. Okay. So, and since what is asymptotes? Asymptotes is nothing but this line is asymptote. So the curve will never intersect or never touches this asymptotes. So this is the approximate shape of the given curve. I think this is clear to everyone. This is the first tangent. This is second tangent. There is a third tangent. So there is a loop between them. And since the curve is symmetric about only this line, curve is symmetric about line y equal to x. So if we fold this curve, the both the part will coincide to each other. Thank you.